Y'all. Okay, I got a few more problems. I think they put chapter 6 as like 6.1 and 6.2. I actually just have it as 6.1, but this would be like the other part of chapter 6. So we could probably go ahead and say it's 6.2. Technically, 6.1 is going to be like the Gauss-Jordan elimination method using, that was really crooked. With like literally didn't even do that. With like 3x3 matrices, 3x4 matrices. And then technically, we'll have some matrices that, they may be called like special cases or something like that. I actually am going to do a few 2x3 matrices. So a 2x3 matrix is in the form of, I didn't touch that, is in the form, okay, so you're going to have 2 rows, right? 2x3 columns. What I'm going to do is actually just show you what our goal is. It's still a reduced row echelon form with ones in the diagonal. And what you end up solving for is your x and y. Here, what you would end up getting is a number of different solutions. I'm going to do an example of each different solution. If you notice, it's very similar to the matrices we were doing previously, except for this one's smaller. Yeah. Okay, so let me go and show you. We have the ability to have one solution, which would be an ordered pair. So an example of that, say we have x plus y equals 1 for our row 1, right, for our equation 1, and we have x, a negative 7y equals 17 for row 2, which would be our equation 2. What we're going to do is actually turn this into an augmented matrix. It's time to wake up, y'all. We're going to turn this into an augmented matrix, which would be 1, 1, 1, 1, negative 7, 17. And then what we're going to do is we're just going to create our pivot point, use that to make the remainder of the row 0, go to our next pivot point, do what we need to mathematically to turn that into a 1. If needed, use that pivot point to turn the rest of the row into a 0. Once you have a row reduced echelon form, you then have the values for your x and y variables. And like I said, it will be one of these different solutions, okay? So let's say that we notice this is already a 1, right, which is great. Our goal now is to just turn this into a 0. Because it's a 1 in row 2, column 1, we're going to use row 1, column 1, right, our pivot point, to turn that into a 0. Because they're the same value, I just need to have an additive inverse. So what I'm going to do is a negative row 1 combined with row 2, and that's going to give me a new row 2, correct? So my row 1 remains unchanged. I can just write that. If we come right here and we actually do this work, which is a negative row 1 plus row 2 gives us a new row 2, negative, right? And then row 1 is 1, 1, 1. Add to that row 2, which is 1, negative 7, and 17. What we end up getting here, negative 1 plus 1 is 0. Negative 1 plus a negative 7 is going to be a negative 8. Negative 1 plus 17 is going to be a positive 16. And so going ahead and filling in those values for our row 2, we have 0. Good, that's what I wanted. -8, 16. Okay, so let's go ahead and look now. I had a pivot point and I turned the rest of the row into zeros, which is great. Now we're going to go to our next pivot point. I need to turn that into a 1. The way you turn a -8 into a 1 mathematically is to divide it by -8. I don't know. I don't know why I've yelled so much. It's 7:30 in the morning. Definitely not that tired. So let's actually take our row 2 and let's divide it by a -8. Doing this math is going to give me a new row 2. So let's go ahead and come right here and let's do this math. Let's go ahead and draw our matrix. I noticed that row 2 is the only one changing. Row 1 is not. Let's do this math. Row 2 is 0, -8, and 16, correct? Let's divide that by -8. This is going to equal my new row 2. 0 divided by anything is 0. 8 divided by 8 is 1. Signs are the same, so it's positive. 16 divided by 8 is 2. Signs are different, so it's negative. That is now my new row 2, which is 0, 1, and a -2. Now that I have this pivot point, I'm going to go ahead and use it. What I need to do is turn this into a 0. So mathematically, I'm going to use this pivot point, right? If I combine those two together just the way they are, I would get a 2. But if I make my row 2 like the opposite of what it is now, right? So multiply it by -1 and combine it to row 1, then that's going to become a 0. I swear I'll stop soon, y'all. So what I'm going to do is I'm actually going to take a negative row 2. I'm going to combine it with row 1. Doing this is going to give me a new row 1. So let's actually do this math right here. And what I would get, let's do my matrix first, y'all. Row 1's the only one changing, right? Because this row's already in like echelon form, I know that my y is going to be a -2, correct? So but I'm still trying to get the top row to be right. Still feel like I need a yawn. So I'm going to do negative row 2, which is 0, 1, -2. I'm going to add to that row 1, which is 1, 1, 1. The answer that I get here will be my new row 1. -0 plus 1 is just 1. -1 plus 1 is 0. That becomes a +2 plus 1 is 3. Those values are 1, 0, 3. Notice here that my 1s are in my diagonal, which means those are my x and y values. So what I have here is that my x equals 3 and my y equals -2. I can write this as an ordered pair, and that means that I have one solution to this matrix, okay? Okay, so I'm actually going to do these videos individually, just time-wise, trying to see what the best time frame for one video is as far as uploading it. When we come back, I'll do an example where our answer is infinitely many solutions, and we also have an answer where our solution set is an empty set. Okay, I'm going to go ahead and explain both of those just to go along with what I'm going to explain. Let me show you right here. I know that if I have the matrix in this form, can y'all see my mouse? I don't know if you can or not. Since I have the matrix in this form right here, that tells me, because this is my x and this is my y, more specifically, if you write your equations, this is where your x is and this is where your y is, right? Those being ones is what gives me these values as my x and y. Okay, so what we need to look out for is if either of these aren't 1. Okay, that's what helps us define whether it's empty set, infinitely many, or one solution. Okay, so if y'all have any questions, make sure y'all ask. Thanks, y'all. Bye.